Hello, folks. So this is the part 4 of learning Rust as part of the 100 days of Rust. By the way, if I finish 100 days, I'll expand that to 200 days, 300 days, and so on, I guess. Uh, I'm just hoping to just keep learning small stuff in Rust. So now we actually see the variables exercise, like the one exercise this being done. This is the third one, and I'm going to go to the fourth one. Before we go, we actually haven't used the hint anywhere. So I'm going to actually try out hint over here or just press enter. It says unknown command, blah, blah. It says unknown command, enter unknown command. I can type help. It says commands available to you in watch mode, hint, clears the screen, quits watch mode, help displays this help message. And you can say clear, and you can run enter, and then you can say quit. We hope you're enjoying learning about Rust. If you want to continue working on the exercise at a later one, you can simply do watch again. So you see it runs everything like one by one. So now I'm gonna actually do this, right? Type hint over here or just help. You've tried out clear and quit, so I'm gonna try hint. The declaration on line 8 is missing a keyword that is needed in Rust to create a new variable binding, right? So it's called a variable binding. Interesting. So this I've heard this term today in another exercise when I was doing it. We'll come to it. So they call it as a variable binding, and it's new variable binding. Cool. I've usually seen it as like a new variable, declaring a new variable and things like that. And they do call it as a declaration on line 8. And it's missing a keyword, so let was the keyword. Cool. So now I'm going to actually clear this up and remove this I'm not done so that we can move on to the next exercise, which is the next one over here. So here you can see compiling of exercises and variables. Variable 2 failed and type annotations needed. Okay. Considering giving X a type. So aborting due to previous error. For more information on this error, Rust explain. So you have the error code over here, E0282. So I'm going to type that out over here. And this will give you like a less kind of thing. So I'm just using cat to easily scroll up and down. The compiler could not infer a type and asked for a type annotation. RNS code example. Okay, interesting. I haven't like used any of these functions or whatever. Hello characters, probably reverse. Yep. It's popular in like I think JavaScript, but it has reverse. This is rev, and then collect. This error indicates that the type inference did not result in one unique possible type. Okay, so looks like Rust can infer your type. I think that's what happened over here when we were actually doing. I mean, you can notice here that this code does not have like any sort of like type reference. Like it does not say where any type like int or whatever, right? It understands, it infers from this that this is a I32. So if you hover over this, it says it's I32, and that's all, you're good to go. So this is also I32, right? And you can see that being shown here. Now, in this case, apparently in this case, we don't have a type, and it looks like there is no one unique possible type. It did not result in that. Like it's trying to infer the type from the right-hand side for the left-hand side, and extra information is required. In most cases, this can be provided by adding a type annotation. So they call this extra information like basically the type annotation. And sometimes you need to specify a generic type parameter manually. Okay. A common example is the collect method on iterator. It has generic type parameter with a form from iterator. Okay, I have no idea what these are. The collect or the iterator are like generic types. Generics, I haven't actually learned generics in Rust. We'll learn, which for a character iterator is implemented by vec. I'm assuming it's vector and string among others. Consider the following snippet that reverses the characters of a string. In the first code example, the compiler cannot infer what the type of X should be. Is it vector of character or string? That's a string of characters. They are both suitable candidates apparently. To specify which type to use, you can use a type annotation on X. Okay, so you can say vector of characters, or you can say string. And apparently it is not necessary to annotate the full type. Basically, there are two types over here, vector and then character, I guess. So once the ambiguity is resolved, the compiler can infer from the rest, infer the rest. So here you can say underscore, I guess. Another way to provide the compiler with enough information is to specify the generic type parameter. So it looks like collect is actually a method that is actually a generic functional that takes a it's a method on an iterator, not a function. I think function is like, I'd say, I don't know, in this case module package, I don't know what, but methods are defined on, I don't know, structures, or I don't know what they are called in this case. I just know Golang and like Java, JavaScript and things like that. So it's a method which takes up a type as it is a generic as it's a method with generic types as input. So you can say collect, and then you can say vector of character, and then again you need not specify the full type, so you can just say vector of and then underscore, and this should be good to go. Apart from a method or function with the generic type parameter, this error can occur when a type parameter of a struct. So there is a thing called struct or structure. I don't know what's a trait, probably interface, I don't know. Traits, properties, interface, methods. Anyways, let's see. We'll learn. So cannot be inferred. When a type parameter, of course, whenever a type parameter cannot be inferred, we'll get this error. The compiler could not infer a type. And no, whenever a type cannot be inferred. In this case, type parameter, type of a, say, variable and things like that, right? So if so this error can occur when a type parameter of a structure cannot be inferred. In that case, it is not always possible to use a type annotation. Okay, so we can't always use type annotation because all candidates have the same return type. For instance, okay, I have no idea what that means. They have the same return type. I've read this before. Let's try it again. Struct foo t. So you're saying foo is a struct and it has a generic type t. Implementation t foo t function bar I32 0. Looks like this is how methods are given. Like you can give like, oh, this is the out. Okay, this is the return type of the method, I guess. So arrow is supposed to probably tell you the return type, and the last line probably is the return value because there's no return word here. And I've seen some things like wherein they take up the last line as like the end result. And then there is function baz let number foo bar, right? Here you haven't actually mentioned foo. What is like foo? Like foo takes up a generic type, and you can't infer like what is the generic type over here, right? Either you mention what is the thing specifically, or like have a generic thing with reference to this, right? So apparently this will fail because the compiler does not know which instance of foo. Basically, t can be anything to call bar on. So there is bar, yeah. So it looks like this is an implementation of this foo. So yep, that's weird. So it's the same foo apparently. So this is the struct, and these are like the implementation, like the methods, I think, on it. So it does, and the bar is here, but bars, you're calling bar on like what foo? This is like, this is wrong. So change this foo bar to say foo colon colon and then t like this colon colon bar to resolve the error. So you basically have to put another colon colon and then t to resolve that. I guess this is similar to how you put here things collect colon colon, not just like, just put things like that, but you have to put colon colon and then put the, angular braces, angular brackets. So in our case, it says consider giving X a type. So how do you give a type though? You give a type by giving colon and then give the type, right? So I think that's what we notice here, but this is actually not done by us. This is actually a drawing on top of our code. So let's go to this. Let's go to this exactly. Oops. And yep, we are here. We say colon, and then we say I32. Learning from here, like, it's a integer 32, or like, I don't know if it's unsigned signed integer, but this works, right? So I've given a type annotation. Let's go back and check what we have. Okay, it's still failing. We have a different error apparently. So it says use of possibly uninitialized variable X. Interesting. So it says it's possibly uninitialized, meaning it's possibly not initialized or given an initial value. Okay. And there's also an error code. So I'm going to actually try out, explaining that error code to see what they say. And this occurs over here in line 8, right? In here, use of possibly uninitialized X. So let's go here and let's do this. So it says it is not allowed to use or capture. I don't know what a capture means. I've read this before. But yeah, using an uninitialized variable, I can understand. You use it, you refer to a variable, an uninitialized variable. But what does capturing a variable even mean? Using a variable, I understand. What does capturing a variable mean? I have no idea. Something to explore later on. So yeah, erroneous code example, latex I32, so similar to our example, error, use of possibly uninitialized variable. To fix this, ensure that any declared variables, basically variable bindings and all, are initialized before being used. Interesting, right? So before you use a variable, you have to define, you have to initialize it. You have to define an initial value for it. So here you say equal to 0. And then you say things like this, it's all fine. But if you directly use a variable without defining its initial value, it gives an error. Interestingly, so prior to this language Rust, I still do, and I used to do a lot of Golang. So in Go programming language, it has a thing called as zero values. So every variable, if it has a certain type, let's say here this 32-bit integer, whatever, every type has a zero value. So if you don't initialize or give a value, like if you just leave it at it, like, declare the variable but don't give an initial value, it actually picks up the zero value of that variable, right? So for example, for strings, it will be empty space. For numbers, it will be like, say for integer, it will be just like, 0, and things like that, right? For pointers, it will be null and things like that. Interestingly, in Rust, I guess there are no zero values in Rust, or at least that's what it seems like, because if you try to use an uninitialized variable, it does not take a zero value, or it does not assume a zero value. Instead, it forces you to actually initialize the first, like, initial value. So you have to initialize the variable and not just declare it. So looks like there are no zero values here. So that's an interesting idea. In Golang, you have to know the zero values of different kinds of types. For struct, for pointer, for integer, for everything, right? For Boolean, like I think it's false and things like that. So let's go to our code. So here, we have to go to our code, and let's say we initialize the value. So it's basically, if you read the code, you can understand why this error is coming up, right? If it was Golang, it would have just assumed it's 0, and 0 is not equal to 10, it would have just said X is not 10. But in Rust, you have to define an initial value. So let's say I say equal to 0, and let's go back here and let's see if it's compiling and it's running. Awesome. So X is not 10 because X is 0. X is 0 equal to 10 is false. So it comes here. Let's just say 10, and does it compile? Yep, it compiles and it says X is 10. Awesome. So here you can see how this is pretty cool. You can provide a type annotation, and then you can provide this value. And since you have provided this value, you don't have to actually even give this type annotation, and it will still work, and it's still the same type annotation. But yeah, this is just an explicit thing, I guess. And there are like more types over here. You can see that there is 16-bit, 32-bit, 64-bit, and all that, and then 8-bit and all that. So can you give, say, 8-bit and then provide, say, 1000? Let's say 10,000, something like that. So literal out of range for I8. So this is something that I tried before, so I just want to show that. So I believe there is some bit and like some overflowing and some problem here. You can't provide such a big value for such small number of bits, I guess. So the literal, okay, so apparently this has negative and positive. So basically signed integers, not unsigned. Signed meaning like negative sign is there. So basically both negative and positive numbers. So the literal 10,000 does not fit into the type I8 whose range is minus 128 to 127. So consider using the type I16 instead. Awesome. So I can use I16. Let's go ahead and use I16. Oops. Let it compile. Awesome, it works. I typed I166, right? So let's see what it says. So it says cannot find type I166 in the scope. So it basically understands that it's a type because I put it after colon. I put it after like let variable name and then colon and then put it here. So here you can only mention a type name, right? You can't mention say a variable's name. So it's looking for a type I66, sorry, I166, and a built-in type with a similar name exists. So wow, so that's awesome. Like it's looking for a similar name. Imagine that, right? So from I166 to I16, right? And then it's telling you that you can use that. I mean, there is a thing, maybe you want to use that, or it's just saying it cannot find it. Like, let's explain this and see what it says. Cat. So here you can see a used type name is not in scope. Interesting. So it says it's not in scope. It does not say it's not defined. It's just not in that scope. It's not defined in that scope, or it's not present in the scope, right? So there are some things, implementation, infiltrate. I have no idea what these are. Function, struct, no idea. No idea. Use. Okay, so these are some stuff that I have no idea about, like because they're using some stuff like the colon and the use itself is like pretty new for me. So I have no idea what is going on here. But one thing you can try to understand like at a high level is that this, right? Here they say implement something, type name something is not in scope. Okay, so here trait foo bar n, type name n is not in scope. Okay, t is not in scope. Okay, to fix the error, you do struct something. So now you have defined that something is a struct, or you have defined a type. So it looks like you can define types using this type, and then it just picks it up. And then you can define your type T by providing this generic. I think this is probably a generic. And then another case that causes this error is when a type is imported into a parent module. To fix this, you can follow the suggestion and use file directly or use super file. Okay, I have no idea what those are. But looks like this is about some importing and whatnot and getting your type available in that scope. So either use super file or use a standard file system fs file, and then you should have file. So I guess file is coming from this basically. Yeah, something regarding like getting types defined in other say modules. I don't know. So and something called as like parent module, child module. So there are many things. But in this case, let's just fix this. And let's say 216. What does it say? Does it still say there's a similar name I16? Nice. Let's just say I16 and let's increase this value, right? Let's just increase this value to a really high number. Okay, awesome. So apparently for I16, the range is 32,768 to plus 30,000, I mean minus to plus 30,767. So you can use I64. Let's just use I64 here. And then this should be available. If I put some more zeros, let's see if I can actually handle it. It can't handle. So it says use unsigned 64 now, like because this is a positive number. Now so basically the value, the literal this big number does not fit into the range of signed integer 64-bit, whose range is this -9 something to +9. But if you use unsigned, maybe it's pretty big. So I can use say unsigned 64, meaning positive bits from I think probably 0 to a very big number. But can I put some more zeros here? Will it work? I think it might just work. No, it doesn't. Wow. So whose range is this to this? So I've just exceeded that limit. Overflowing literal, so it does not fit it. You can't do anything now. There's nothing above the 64-bit. So I can't use such a big number. I'll just have to use different ways to represent such big numbers, I guess, like say an array of numbers, multiple numbers, like, which you put together to form such a big number. And then do computations on top of that. Like you need to have better structures to represent pretty big numbers, I guess. Because 64-bit is the maximum you can go for a given one value. So yeah, now I guess you can actually fix this and go to the next exercise. And like I'll put 10 here and I can just remove I'm not done and we should be good to go. Cool. So yep, I will stop this video. That's all I had for this video. I'll remove I'm not done in the next video and then we'll look at the next exercise. Thanks for watching. I'll see you in the next one. Bye-bye.